It appears to be making a video. Let's make sure pretty much. So, draft physics on the subject of gravitational lensing and the effort to give you reason to suspect that maybe conventional physics hasn't quite got it right. And this is probably a good subject just to show how physics is done, and it's done poorly. It doesn't make much sense when you really look at it, if you pick at it, and that they don't pick at it any. So I don't know exactly why Einstein plays with this subject. I don't know why he needed to create a gimmick that basically declared photons twice as sensitive to the force of gravity as any other object in the universe. Suspect it has something to do with his field equations, but I don't know exactly why photons being bent by gravity would be at all necessary. But anyway, so we have two kinds that are solar lensing around small, dense objects like the sun, and then the other kind are these cosmic lensing images that little hook of light over here, little smiley face over here, some kind of thing like that around some cluster of stuff that apparently they say is creating enough gravity to cause the effect. Yeah, neither one is very good science, and I think for kind of obviously not good science. So anyway, the thing that occurred to me is that the first most obvious problem is it's the wrong shaped lens. And I'll read what I wrote anyway. A focusing lens bends light on the outside more than it bends light on the inside towards the center, and a gravity lens would do the opposite. How is this apparent paradox remedied? So I haven't seen a good remedy. I have been directed to a website where they make a fake lens that's the correct lens, and they're able to create images of objects very close, but there's no evidence that it can take objects that are far away and magnify them or do any of the things that is suspected to be the byproduct of gravitational lensing. And just through your intuition you can sort of understand that if this wrong shaped lens had any value as a focusing lens or as a lens for seeing objects far away, that we'd have telescopes with them in it, and we don't. So obviously it's not a working lens either for creating an image or for seeing things far away. Alright, and then there's the Eddington experiment, the solar lensing experiment done with an eclipse to see things near the sun, the objects that are in the, they're obviously not near the sun, they're way far away, but the light would be bent around the sun. And that experiment's never really been successfully done a second time. I don't think it was done successfully the first time. Very marginal data. It's kind of famous for how lucky he was to get any images at all, and the fact is the images he got were 25%, 10% of what he was hoping for in terms of their quality. Very precise kind of measurements you have to do, little blobs of light, blah blah blah. And so Einstein was made an international hero based on that very marginal experiment, and since then it's just been stated that it's some kind of truth that light is bent by gravity, even if it doesn't make any mathematical sense, or even though there's not consistent evidence. So I guess this is more of the stuff to go through. So the problem is that any kind of experiment you do near the sun is going to get a problem of scatter, because there's a whole bunch of little particles around the sun. You can go into lots of theory about what the consequence of that is. So they've done some radio experiments where they send radio signals, or they're receiving radio signals, and claiming that they've gotten some results that indicate lensing, but they really can't separate those from scatter. especially when you consider things like the particles that do leave the sun. There's more of them heading in towards the sun than are heading out, because they move slower going back to start with. What's the other reason? Yeah, that's mostly the reasons. You know, even though the sun is ejecting a lot of material doesn't escape the sun's gravity and ends up going back again to the sun. So the further away from the sun, the more likely it is you're going to have objects that are moving towards the sun than away from the sun. That could be also a reason why you might have some evidence that there's some pulling force, but it just might be the byproduct of scatter. But again, that's kind of a complex argument, but it's sort of not dealt with, you know, as a real problem in viewing things in atmospheres that aren't clear. Alright, so I've already stated the Einstein gimmick, which was to make photons, the only thing in the universe that's affected twice as much by gravity. And it's not much of an explanation for why we should believe that's true, or why it would be the way the world works. Why do we need that to be a truth? So cluster gravity would not be spherical or symmetrical, and would not produce partial or complete Einstein rings. So most of the galactic images, or whatever cosmic images of lensing, are in places where the gravity is insanely weak to start with, but they have a shape to them indicating they're the product of some sort of spherical gravity. Yet these aren't lensing images from around things that are spherical. They're things that are galaxies that are flat, and then there are groups of galaxies which don't create a symmetrical gravitational field at all. So there's no reason to believe there would be any Einstein ring type effect from gravity that's not spherical or symmetrical. So indicating that the effects they're seeing can't possibly be the byproduct of gravitational lensing. Then really an important one that's just totally dismissed by physics is the absence of consistency in the theory, in the sense that if there was gravitational lensing, we should see all kinds of effects. If you hold up a regular lens, you know, all kinds of distortions happen. Little bright thing can be huge, you know, and we're supposed to believe that none of these gravitational lenses ever have anything close fly behind the lens and create a gigantic blob of light. We don't see any of the effects that we would see if lensing was a real effect. Not on this list. I should have added it was gravity doesn't produce the same shape as a regular optical lens. The inverse square law is a very harsh curve, and you know, an optical lens has a kind of a smooth curve, and so most of the galactic images are not just little streaks of light, they're clumps of stuff, and you can see little suns and different little things in it, like it was a mixture of something, like a galaxy. And none of that image data would be preserved with a gravity lens, because the amount of bending would be too severe and it would distort the image substantially. So theoretically we shouldn't even be able to get any data from anything of any thickness, so we should just see a sliver at best, and that's not what we see, and they don't bother explaining those contradictions. The evidence contradicts the theory just as much as it defends it, and that is a huge indication that maybe this whole theory is not correct and should be rethought through, and it's just not a good idea. They ought to let it go. Again, I don't know why it's a necessary feature of Einstein's theories, but it just seems like a gimmick. Doesn't seem like there's any basis for it. So I guess I'll try to draw just the simple parts, explaining the misshapen lens and the consequences of it. So the idea of a regular lens, it clearly bends the light more the sharper the angle. So the angle is essentially deciding how much the light gets bent. So it takes light that's diverging or creating a large image, and it refocuses that large image back into a small image for us to see it. And that's the function of it. So it needs to bend the light more on the outside and bend the light not at all that might be straight through. And a gravity lens, as pointed out, is doing essentially the opposite and doing it rather severely. So it's some other shape of lens, in the sense that it's a lot of bending in the middle and no bending on the outside, so any divergent light just drifts off. Well, it actually just goes straight. And so you're not going to collect light at all. It's not going to be good for collecting light from a distance. It's not going to have an enlarged image that it projects to a focus. So it's not going to do any of the things you need it to do. It's just going to create insane distortions, because the light coming in the middle would get just bent away from a focus entirely. Just the opposite effect. Can't possibly work to create whole images again. So if you're looking for more than just a point of light, if you're seeing something that has any kind of size to it, any kind of shape, it would be impossible with that shape of lens. And even collecting light from a distant object, you're not going to collect it with that shaped lens. So there's just no good ground theoretically for what they're stating is happening. It just doesn't make any sense. So the galactic images are usually some kind of thing like this. There's a few galaxies in a blob, and then they'll see some weird looking thing on the side over here, and there'll be a little weirdness over here, and they'll all have a little archy shape to them, giving some kind of rough idea that this might have been some kind of lens. But the giveaway is these arcs don't line up. It's never spherical. It's always got some kind of weird shape to it, and there's no connection between some single object and these arcs. The arcs aren't proportional to the size of these objects. They're proportional. If there was one object in the middle, you might be able to justify those arcs. So there's all kinds of inconsistencies. Again, the gravity out here would be insanely weak compared to the gravity, say, in here somewhere in the middle of the cluster, yet we don't see any images where we have lensing in the middle of a cluster or around the objects in the cluster. Nothing. And we should. I mean, the alternative explanation would be if something explodes somewhere in this cluster, you would get things that would symmetrically leave the same speed, and so they would be equidistant from the initial explosion, so they would tend to have the same shapes and be at a symmetrical distance. The more likely explanation is something exploded and stuff got moved into a different position and a different shape because of the movement. So the other point I've made in the past is, gravity is a collection of objects can create gravity, but galaxies are flat-ish mostly. A little bit of density in the center, and the strongest gravity, if you want to be affected by a galaxy, would be at these points here, where there's the most density of matter, and clearly distances out here would be the least gravitational, because there's a bunch of the matter of the galaxy wouldn't really be having an effect. The biggest pieces of it, the arms, containing millions and billions of suns, and all that gravity wouldn't be having nearly as much effect on the object. So when they show images of lensing around a galaxy, for example, you'd have to argue that that lensing doesn't make much sense, because if we're going to see it, we really should see it on the edges of a galaxy, and and we don't see any real images like that anyway. Either way, we don't see too many images around a galaxy, even though galaxies are supposed to have black holes in the center of them and be very dense with matter. We don't see any lensing around galaxies. and where we do see it, if there is any, it's in places that where you would argue the gravity would be much weaker. Yeah, and you know, proximity. Again, it's all this distance thing is really important, and the fact that things are spherical versus flat, and you know, these are all important subjects that are just ignored by physics, and there's just no conversation that can be found explaining these paradoxes, problems. So again, I would argue that the evidence is very weak, and it's reason to wonder or doubt that physics has the right story. Again, photons are essentially, you know, moving the speed of light. Well, so if we found it's magnetism, and so does gravity, and so we have a force pretty much acting on a force which we don't see anywhere else. None of the other forces can be bent. Why would photons be special? What mechanism? There's no mechanism for any of this bending anyway. Why does the photon move towards the gravitational body? What compels it to do this? It's just spooky action at a distance. We're not given any explanation of any acting force, any acting mechanism. It's just some sort of magical thing that things do, and these aren't good enough reasons. So I guess that's probably enough. I mean, this needs a little more detail in terms of the questions, but there are a couple of questions there. Wrong lens, how do you explain that? You certainly can't magnify objects. And why don't we see all the other manifestations of distortion that you'd expect if there was these giant gravity lenses? If they're capable of bending light in these distant locations, they should be bending a ton of light more closer to the gravity. There should be insane amounts of objects being lensed, and we don't see any of it. And then again, the Eddington experiment not reproduced, at least not reproduced in the same sense of using high quality photographic plates, using a telescope of adequate size, and then they had the perfect eclipse to do it in, and nobody did it. They have space telescopes, and none of them ever been used to attempt some gravitational lensing experiments regarding the sun. That these are huge voids in the data database, and I would argue they're there because they can't create this evidence. It doesn't exist, so they don't want to validate the fact that it doesn't exist, that it can't work, that it doesn't work, that it's not the truth. And then they have to admit that for 100 years they've just been talking a kind of crap about reality, and basing their physics on false presumptions. Yeah, so obviously I have an explanation pointing out that gravity is a real force, that it basically is the same force that creates magnetism, and forces just don't bend forces. They have to act on matter, and so none of this is anywhere close to the right answer. And the fact that it's such a bad answer, I mean, it's such a poorly evidenced answer. I mean, my obligation is to provide an alternative theory, and I think I've done that, and point out why the existing theory has flaws, and this is a hugely flawed, very weakly evidenced, wrong assumption. That's all it is an assumption. It never really was a evidence-based conclusion. Einstein declared it, and they went out and tried to prove it, and they proved it with very weak evidence. So I guess that's enough. So till the next time, and till the next subject and such.